Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. We are asked to graph the inequality in a coordinate plane. A coordinate plane. So we have a coordinate plane right over here, and let's graph this inequality. So first things first, we need to graph the boundary line for this inequality, and that would be x equals -1. So step 1 is to graph the boundary line, y equals -1. I'm going to do that in blue, and since this is a greater than, not a greater than or equal to, it's just a greater than, I'm going to do a dotted line. So we need to cross the y-axis at -1 with a dotted line. So there is our boundary line. Now, how do I know whether I should shade the top or the bottom? Well, we could always, guess, look at the inequality, think, oh, bigger than -1. Let's get into the habit of testing a point. So we could, for example, test 0, 0. X is 0, y is 0. So when we plug that in, we get 0 is greater than -1. Is that true? Yes, that is true. 0 is bigger than any negative number. So we will shade the top. The top of this plane, the top half plane, is the plane that we will shade. And there you go. Yeah, step 3 was to shade, and we did that. So there you go, the end. And we can move on to what we have for today. Today we're going to finish section 5.6, graphing linear inequalities in 2 variables. So today, our learning target is that you know what it means to graph in 2 variables. You might already know that. We're going to dig into it a little bit deeper today. And our success criteria is I can graph to find solutions of linear inequalities in 2 variables. So, a little similar to example 2 from yesterday, but we're going to dig a little bit deeper today. So some reminders, some review from yesterday or the last video, depending upon when you're watching these. So we talked about the boundary line is the line in our graph of a linear inequality, and the solutions or the graph includes a shaded half plane. So there are 2 half planes. There's one on this side of the boundary line and one on the other side of the boundary line. And the one that is shaded contains all of the solutions to the linear inequality. All right, good review. If you want to know more about this stuff, definitely check out the last video. Okay, the steps to graphing a linear inequality in 2 variables. First was graph the boundary line. Second was test a point, and step 3 was shade the half plane that contains the solutions. So when the point is a solution, shade the plane that contains a point. So shade the plane that contains the solutions. Okay, we also talked more about these in greater detail in the last video. So if you want to know more about this, check out the last video. And we are going to move on to example number 3, graphing inequalities in 2 variables. So now, check this out. Yesterday, or excuse me, in the last video, and in the entry task, we graphed something that looked like y is greater than 2. Or maybe x is less than or equal to -3. Something like that. Now, wait a minute. I have x and y together. So graphing in 2 variables means that we're graphing on a coordinate plane, but our inequality can still have only one variable. So like in the entry task, when we had y is, or you know, what we had yesterday, y is greater than 2, or x is less than or equal to -3. We can graph these in two variables, even though there's only one variable here. Graphing in one variable is like my number line, you know, 0, 1, 2, open circle pointing that way. This is graphing in one variable. Graphing in the coordinate plane is graphing in two variables. But today we're going to graph in two variables again, but we now have two variables in our linear inequality. Whereas, you know, something like y is greater than 2 only has one variable, even though we're graphing in two variables. So, in this video, we're going to look specifically at linear inequalities that have both x and y in them. So, the easiest way to do this, in my opinion, is if we can get the form y equals mx plus b, or y is, you know, greater than, less than, whatever, mx plus b. So I'm going to add x to both sides. 2y is greater than x plus 2. Divide by 2 on both sides, and I have y is greater than 1/2 x, because this is 1x divided by 2, and 2 divided by 2 is 1. So, step 1 is to graph this boundary line. So let's do that. Plus 1 means that I have an y-intercept at 1, and my slope is rise 1, run 2. And because this is just greater than, not greater than or equal to, I'm going to have a dotted line, or a dashed line. Wonderful. Now, step number 2 is to test a point. And we are going to test 0, 0. We'll test the origin, because it's going to be the easiest to test. And I'll show you why it's the easiest to test. When I plug it in to our inequality, and it doesn't matter if I plug it in here, if I plug it into the y equals mx plus b, or if I plug it into the original, it doesn't matter. So let's plug it into the y equals mx plus b. I have 0 is greater than 1/2 times 0 plus 1. So this is 0 is greater than, what's 1/2 times 0? Anything times 0 is 0 plus 1. So I have 0 is greater than, 0 plus 1 is 1. Is 0 bigger than 1? No. No, it's not. So I'm not going to shade where that point is. I'm going to shade the other half plane. I'm going to shade up here. And that's step 3. Step 3 is to shade. Okay, so you see why testing 0, 0 is the easiest. Because, oh, anything times 0 is 0. 0 plus anything is just, you know, 0 plus 1 is just 1. 0 plus whatever is just whatever. So, 0 is a nice number to work with. Now, let's check and make sure that we were correct. Step 1, graph y equals 1/2 x plus 1. Use a dashed line. We did that. Test 0, 0. They tested it in the original equation, but they still got something that was wrong. So we shade the half plane that does not contain the origin or the top. And hey, 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 that is what we did. So we are correct. All right, now I would like you to try. I'd like you to pause the video and try this problem on your own. Remember that if you get stuck or you can't finish, that is okay. It's all part of the learning process. In learning, we struggle, we make mistakes. We typically don't get it right on the first try, and that's okay. That's all a part of learning. So try your best on this problem, and then unpause it. Do it with me. So step number 1 is to graph the boundary line, but I need this in y equals mx plus b form. So I'll subtract x on both sides, and I get negative 2y is less than negative x. And now I'll divide by negative 2 on both sides. And do you remember what happens when we divide by a negative? Do you remember what happens to my inequality when I divide by a negative? We do the sign flip dance. Do you remember that from chapter 2? Anytime I divide by a negative number, my inequality sign flips, and I have negative x divided by negative 2, so that is positive 1/2 x. So we are graphing. Step 1 is to graph y equals 1/2 x. So my y-intercept is 0. My y-intercept is 0. And I'm going to rise 1 and run 2. Let's see, should I use a solid line or a dashed line? Solid or dotted? Well, this is just, there is no or equal to. We are strictly less than or we're strictly greater than. So I should have a dotted line. Beautiful. All right. Step number 2 is to test a point. Can I test 0, 0? Well, 0, 0 is on the boundary line, so it doesn't help for me to test 0, 0. I want to test something that's not on the boundary line so I know which plane to shade. So we actually need to pick something other than 0, 0. So we can pick literally any other point. Maybe we could pick 0, 1. 0, 1. So that means we'll test 0, 1. We're going to plug that into our original equation. So x is 0 and y is 1. X minus 2y is less than 0. So 0 minus 2 times 1 is less than 0. 0 minus 2, this is negative 2, is less than 0. Yeah, any negative number is less than 0. So, because this was a solution, we need to shade that half plane. The half plane that contains that point, because that's the half plane that contains all the solutions. Woohoo! Wonderful. Alrighty. That's what I have for you today. I know it might have seemed like a little bit of a quick video, but really, we know how to graph linear equations, so the boundary lines was easy. Easy. It was a review. We've done it before. So, the only really new thing we had to do was test the point and color in the correct half plane. So, now is a perfect time to test your understanding, assess your understanding. How are you feeling about our learning target and our success criteria? Do you know what it means to graph in 2 variables? To graph in a coordinate plane? Do you know how to graph linear inequalities when both variables x and y are in the inequality? If you are struggling, that's okay. This was me in most of college. So if that is you, don't worry, but be sure to get your questions answered. If you're feeling, don't have a ton of confidence, but I think I know what's going on, then you are ready to start the homework. And if you're a 3, you are so confident when you finish the homework, you can help your friends and help your peers and even teach your parents about what you've learned in this video. All right. Here are some practice problems that you can try to practice the skills that you have learned in this video. These problems are like example 3 that we did, and here are some others that aren't exactly like example 3, but use the same skills that it took to solve problems like example 3. Let's end our video with a launch, shall we? Today's launch comes from Josie Bissett. I hope I'm pronouncing that right. I apologize if I'm not. Dreams come a size too big so that we can grow into them. I love this. I hadn't even heard of this saying until I went out looking for launches and pictures to use for a launch. Dreams come a size too big so that we can grow into them. Oftentimes when we pick, a dream, or when we have a dream, it seems so crazy. Like, we'll never get there. Like, I want to have a successful YouTube channel. I'll never get there. I want to be on Broadway. I'll never get there. I want to be super in shape. I want six-pack abs. I'll never get there, Sometimes our dreams, or the things that we really want, seem so far out of reach. But they come a size too big so that we can grow into them. Oftentimes, there's a lot of growth that we need to do before we can go after our dreams. Before we can have a successful YouTube channel, we need to be able to take criticism, because people are going to be jerks in that comment section, unfortunately. Before we can be on Broadway, we need to, grow into a talented singer and actor before we can actually have a role on Broadway. And before we have six-pack abs, we need to learn discipline and sticking to something, perseverance, to even when I really don't want to work out, I'm going to work out. And even when it's super hard to get that last sit-up or that last 10 seconds of that plank, I can still do it. So, if your dreams seem too big, that's okay. You're leaving room to grow into them. So, dreams are supposed to come a size too big so that you can grow into them. So don't stop dreaming, don't stop growing, and that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye!